collected until today. In the 2030 years, ALICE and LHCb will do another upgrade. So, what is the future there? Well, first of all, the future of Higgs physics at the LHC is that there is one key question, like the self-coupling of the Higgs boson. One has to search for this very rare process, the di-Higgs boson production, to experimentally constrain the Higgs self-coupling and thus the Higgs potential. So one of the crucial measurements for the next 20 years is the Higgs boson pair production. The next priorities, in plus and minus Higgs factory. As I said, you have to dig into the properties of the Higgs as much as you can. So highest priority is the E plus and minus Higgs factory, which could be a future 100 TeV hadron collider, the first step of this future 100 TeV hadron collider. And here, CERN should do technical and financial feasibility studies for such a collider. And that shows you the FCC, the Future Circular Collider program for the next decades. So on the left plot, you see the layout, you see the small circle, which is the LHC, and this large circle is up to 100 kilometers circumference, the FCC. In the middle, the first phase of measurements would be done with E plus E minus, FCC-EE, and then in the second half of the lifetime, it would be hadron-hadron collisions. So it is a forward look if such a project would be realized. It's a forward look until the end of this century. CERN does not do neutrino projects on its own land. However, there are long baseline projects in neutrinos in the US and in Japan. And CERN and Europe should participate in these projects. There is in particular the long baseline neutrino facility supporting the International Deep Underground Neutrino Experiment June at Fermilab in the US. And I show in particular this one because this project will be the first internationally conceived, internationally constructed and internationally operated mega science project hosted by the Department of Energy in the United States. It is amazing, it's only now that they do the first real international project from the very beginning. And this is something which I like very much, that this is also starting now in the US. In June, the experiment itself is again a global collaboration with roughly 50% US and 50% non-US participation. And it's a collaboration which is growing every month. Then, of course, CERN does not have only a large accelerator, it also has many other accelerators and experiments. So, we should look at high-impact scientific diversity programs complementary to high-energy colliders. And that shows CERN's diverse program. You see all the accelerators displayed on the left-hand side. On the right-hand side, you see the list of these experiments, of these facilities. And there are altogether roughly 20 projects outside the LHC with around 1,200 physicists. So these are all small experiments, but very important to bring our knowledge forward. Not yet an experiment, but the preparation is in yellow on the right-hand side. It's a neutrino platform. The neutrino detector R&D for experiments in US and in Japan. And this neutrino platform is shown in the plot here. in the photo. And we decided in following the 2013 strategy to update CERN's neutrino involvement. And CERN since then operates the so-called neutrino platform, which is there not only for CERN people, but for European researchers participating in long baseline neutrino experiments. And an example is the development of liquid argon TPCs for the DUNE experiment. So there's a strong involvement by CERN in the DUNE experiment, but also several R&D projects for T2K and hyper-K. CERN is also doing a study for physics beyond the collider, and I cannot go into detail here, but it's a study which was launched roughly 5 years now to exploit the full scientific potential of CERN's accelerator complex. So it was calling, or is still calling, for bright ideas, what to do with the accelerators. And you see there are quite a few opportunities mentioned in this gray shaded area. So CERN is an example of a unique international institute, an example for a global research infrastructure. And it's vital for large-scale projects. And in turn, that allows to support the sustainable development of science and of technology, which, as I said at the beginning already, which is necessary for the upturn and growth of everybody's economy. But again, let me point out, CERN is only strong through its close collaboration with national institutes. Alone, you are lost. You need collaboration. And experiments are also very good examples of large international collaborations. And when I give talks to politicians or to industry people, they are always asking, how does it function? How can you do that? What is the glue which holds these people together? Well, first of all, it's a place where people learn to work together. And it's nice, it's at the same time collaboration and competition. It's a good opportunity to recognize differences, but then you have to accept them. And you gain a lot by accepting these differences and to learn how to use them. It influences your way of thinking. And it's an experience which can be used by individuals and in other fields. And I know quite a few fields where I would have liked to see such an approach. Specificity here is also that the management is through common goals. The management is by convincing partners. And this is something which is really admirable. So another key message here is that international collaboration is mandatory in many areas today, not only in science. However, and that's very important, it needs trust between the partners. And this trust you need for a long time. It needs commitment and a sustainability from all the partners. Long time, trust, and commitment. And I think science is an excellent example that this is possible. One problem, of course, is that future projects need long lead times. And also the research results might take long times. You know the example of the Higgs boson. It was discovered 48 years after its theoretical prediction. Gravitational waves are an even more extreme example. Here is the original measurement, the first measurement of the gravitational wave. Predicted in 1916, discovered in 2016. 100 years. And now it has the detection of these gravitational waves have opened a new research window into the universe. So, 48 years and 100 years. The question, of course, is why does it take so long? And the answer is reasonably easy. You need for such experimental observations the development of new forefront technologies. So that means large research infrastructures are not only doing research per se, but also research in technologies, forefront technologies. So technology and innovation are one of the other pillars of such research infrastructures. I said already that large-scale science projects address fundamental questions, but they provide, at that time, unique equipment, very importantly stimulating ideas which attract good people. They give the occasion to bring people together, and in particular, they have challenging requests for high technology and innovation. And medical application is a prime example of not only particle physics, but also particle physics spin-off. It combines physics, IC technology, biology, and medicine to fight cancer. And you all know, with a PET scan, you can look at the position of cancer cells in the body. And the PET scan is one thing which is, again, to be, to be taken into account when you think of timelines. So, positrons were predicted and discovered. I think the time between prediction and discovery was only 3 years, so that was fast. But altogether, in the late 20s of last century, it was pure basic research. It then took more than 40 years until PET could be used in hospitals. And then it took another 20 years that the next PET generation used, interestingly, crystals and electronics developed for LHC detectors. So you see how hand in hand, very well basic and application goes. And when you have the location of the tumor, you can try to destroy it and to heal the patient by targeting the tumor with either not only photons, but also protons or ions. And the leadership in ion beam therapy nowadays is, as far as I know, in Europe and Japan. And this is the very important message. It's a virtuous circle. Basic research, innovation, applied research. So the synergy between research and innovation does not only result in societal and economic impact, but also, and very importantly, in the creation of enhanced opportunities for further development. Basic research brings forward also the applied research. The applied research brings forward the technologies, and with these improved technologies, you can do improved basic research. This is an important circle which needs to remain strong, to be unbroken, and to be supported over long term. If you break that circle, at whatever point, you are only losing out. Maybe not on the short term, but on the long term, definitely. So, I have 2 or 3 concluding remarks. To my mind, science and technology in the next decades with strong sustained support for research, with trust developed and trust kept between all partners, with international collaboration, and with scientists as ambassadors for peaceful cooperation, will pave the way towards a sustainable future. But you need all four of these points. And especially as we see today, trust is very important. Let me end with the last paragraph of the editorial in the British newspaper The Guardian, published in 2015 on the occasion of the restart of the LHC. The search at the LHC will invoke mini black holes, antimatter, quark and plasma, extra-dimensional space. The partnership so far has spun off colossal technological and computing rewards. But in the mind of the editor here, this is not the point. The point is that Europe, and I want to add its partners, is working together in a thrilling intellectual exploration that can have no conceivable commercial or political payoff, but could, in some still intangible way, enlighten all humankind. In these otherwise murderous and mean-spirited times, that is something to salute. That was 2015. Today we are 22. And it's still the same. Maybe it's even worse. However, I'm optimistic that science can contribute to a better and sustainable future. Thank you.
Thank you. Thank you, Lord, for the clear message to all of us, to the societies and to all the countries. Indeed, so now the talk is open for questions, if there is any.
Now I have to find the button how to.
Yes, because.
I can.
This is Vikas here.
Sorry?
This is Vikas here from conference. I want to thank you myself, at least in two dimensions, as you say. It's not a question, it's a point of discussion that I want to propose. You see, it seems to me that CERN is also an example which you mentioned of peaceful coexistence of countries who fought bitterly just some years ago. I'm talking about the Second World War. In our part of the world, we have continuous trouble with our neighbors, one way or the other. I, in my small way, have tried to install some kind of laboratory, a miniature CERN, maybe in India, to include these countries like Pakistan and China, to do experiment and research and sustain progress. Now I'm very grateful if CERN, as the biggest venture on this collaboration, can help us. Okay?
Thank you, Vikas. Rod, you want to comment? Hello?
Yeah, sorry, I switched off my mic.
Ah, okay. Did you hear Vikas' comment?
I heard maybe 55% of his comment. But I can well imagine that he was essentially resonating with my last remarks, and in particular with the role of CERN concerning the help through this international collaboration for the national institutes. Is that correct?
No, he was going beyond that. He was trying to see that whether it is possible to have a mini CERN here in this part of the world, and India, and which can be, a place for cooperation of the local countries, India, Pakistan, China, and so on. And if that is possible for CERN to help in that direction.
I see. Well, I can relatively easily say something because I'm no longer in power, but I don't want to stick out my neck here. I mean, CERN could definitely help, I'm sure, giving advice, etc. However, I fear the times since the mid-50s and today have changed. Big projects need much more time nowadays to be approved. So, I don't know what to say more about this. I would wish to have such a center in Asia, definitely. I'm convinced that science would get much faster and much better forward if you would have 3 of such centers. One in the Americas, one in Asia, and the one in Europe. And what you maybe should do, or could do, is to really learn from the CERN experience. What is needed and how to do that. What is needed, I think that didn't change since the 50s, but how to do it has definitely changed. So that's all I can comment on that. I think Bikash is right. It would be fantastic, but I'm slightly skeptic. I'm always an optimistic person, but I'm slightly pessimistic that now the time is right to do that.
Thank you, Ralph, for your comments. And Subir.
Hello, Ralph. This is Subir Sarkar from Oxford. If I could ask you a slightly uncomfortable question, which, however, is in many of our minds today. It was commented that during the darkest days of the Cold War, CERN was a meeting place for scientists from west and east of the Iron Curtain, and it maintained that link through various rather significant events which threatened to jeopardize security in Europe and all over the world. CERN, the scientists continued their collaboration. But we have seen recently that the reaction to recent events has been for Russian scientists to now be excluded from CERN. No doubt you have to obviously follow what's decided by the Council democratically and so on. Nevertheless, it makes one wonder whether this commitment to international cooperation regardless of politics isn't somewhat fragile, because that is something that would be particularly relevant for the other CERNs that you talked about. For example, the synchrotron light source in Amman is one example, but any others. There are always going to be geopolitical tensions. And did you not, if I understood you correctly, you are arguing